Hello, and welcome to Lesson 30 of this Introduction to Calculus with Wolfram U. The topic for this lesson is volumes by cylindrical shells. So let's begin with a brief overview of the lesson. So in the previous lesson we learned about the disk and the washer methods for finding the volumes of solids. So as an example of the disk method, let's say you have the function f of x equal x square and you rotate that around the x-axis from 1 to 4, you get a solid of this type. And to find the volume, what you do is you break up the solid into disks, and each disk then has a radius of x square, the value of f of x. So the area of the disk is pi times r square, times of course the height, which is the infinitesimal volume, and then you get the integral of that giving you the volume of the solid. The washer method is very simple and similar because all you do is instead of working with one disk, you simply subtract the volume of two disks, the outer and inner, and so basically you're working with washers or rings or annuli or whatever you call them. Now, a slightly harder example, suppose you have the function shown over here and you want to revolve it around the y-axis, not the x-axis. Then it's not clear what one means by the inner and outer radii. And so the goal of this lesson is to talk about the so-called cylindrical shell method, which makes this example and similar examples very simple. So let's build some intuition for the method. So let's say you want to find the volume of a solid. You break it up into pieces, but these pieces are now going to be shells rather than cross sections. And because each shell looks like a cylinder, so it's called the cylindrical shell method. So here's a typical cylinder. It's very thin. It has an outer radius of R2, inner radius of R1. So that is the difference in the volumes of outer and inner, which will give you the volume of the thin shell. So if you factor a little bit, you can rewrite it as 2 pi h times the average of R1 and R2 times the difference between R1 and R2, like over here. Now, because it's very thin, you can let R2 approach R1, in which case the difference over here becomes dr, and the average becomes just R1. Now, because you only have one R left, so you might as well call it R, so the volume now becomes 2 pi hr dr. The question is, what's h? Well, h is the value of the function f as a function of r. So the height h becomes now f of r, so you have a very nice simple formula for the volume by the method of cylindrical shells. So to go back to our example, the introduction, you have this function f, 4x cubed minus x raised to 4. You want to work out the volume, so you simply do 2 pi r times the value of the function over here times dr. You work it out with integrate and you get back the result. Okay, now the question is, which method should you use, the washer or the disk method or the cylindrical shell method? So let's say here's an example in which you have two curves, x squared and x cubed, but you want to revolve around the y-axis. Now, with the washer method, you could rewrite things as cube roots and square roots and get the answer. But in this case, it's much simpler to simply work with the cylindrical shell method and you get back the same result. So you do get the same answer, but the question is which one to use. Well, that's up to you, but typically the cylindrical shell method works well when the axis of the cylinder is the same as the rotation axis. Okay, so some minor variations. So let's say you have a function like over here and you want to rotate it around the line x equal to 6 rather than the y-axis, let's say. Then what you do first of all is you find the radius, but keep in mind that the radius is now going to be 6 minus x because you are counting from x equal to 6, so that's the radius. You have 2 pi times radius times function value, and you get back the answer with the cylindrical shell method. On the other hand, if you have a negative axis, so let's say you have x equal to -1 over here, and you have this function. Now if you look at the radius, it's going to be x plus 1. And so your formula is slightly different. You have 2 pi times x plus 1 times f x dx. You work out the answer and you get back the volume in this case. So we spoke a little earlier about comparing the two methods, washer disk and cylinder. So let's take an example where the disk or washer method works a little better. So let's say you have fx equal to cube root of x. You now revolve around the x-axis from 0 to 1. If you try the cylindrical shell method, things become a bit harder because now the shell height is horizontal rather than vertical. So if you had to apply the cylindrical shell method, you would first of all rewrite the function as a function of y, then work out the shell radius, then work out the integral. But with the disk method, things are much simpler because you simply have cube root of x as the function. So you apply pi times r square dx, integrate from 0 to 1, and you get back the same volume. So in general, both these methods, the cylindrical shell method and the washer disk method, have advantages and disadvantages, and you must decide which one is better suited for your problem. Okay, so that brings me to the end of the lesson. So basically what we learned is that the cylindrical shell method is another nice way of finding the volume of solids. But this method works by breaking up the solid into cylindrical shells. Those shells are very, very thin, and the height of the shell is the value of the function. So sometimes you'll find that the cylindrical shell method is much easier, and it will be very cumbersome or even impossible to apply the disk washer method. But other times you might find that the disk washer method is a lot easier to understand and use, so you might prefer that. And just to review the formulae for the lesson. So first of all, if you revolve around the line x equal to x naught, where x naught is positive, then you get an x naught minus x as the radius. So think back to the example involving 6 minus x. On the other hand, if you have a negative or 0 value for x naught, then you'll have x minus x naught over here. So think back to the example which had an x plus 1, which really was an x minus minus 1. So those two very simple formulae tell you what you need to do for the cylindrical shell method, and that makes it a very simple method whenever it works. So in the next lesson, we'll talk about the average value of a function with integration. But before doing that, do review today's lesson. It's a very important lesson. It tells you how to find volumes of very difficult looking solids, and it really shows you how powerful calculus is. So I'll stop over here. Thank you very much.